t. So, try to get one that's got a. I'll go with this one. I like it. Identify the values to make each function undefined. What is that? Where is that? You know, rational function. When is it undefined? When the denominator equals 0. So I'm looking here at, in this particular one, I'm looking at where, oops, where, oh, come on now. Grr. So I'm looking at where that equals 0. So 5 plus x equals 0. So that's when x is negative 5. So if x is negative 5, the first function, the first rational function, is undefined. Okay? Second one, I'm looking at where 12 minus x is equal to 0. So that would be where 12 is x. Right? Okay. And in the last one, I'm looking at where 2x squared minus 5x minus 3 equals 0. So let's see. 2x and x. I'm going to go 3 out here. I'm going to go minus 3 out there actually. And I'm going to go plus 1 in there. That gives me negative 6x plus 1x is negative 5x, which is what I want for that middle term. Okay? So then once I have that, then I say 2x plus 1, bad x, equals 0, or x minus 3 equals 0. So then here 2x would equal negative 1. So then x would be negative 1/2. And over here x would be 3. Questions on that?
What about stuff for like the top or for the numerator? What?
Don't worry about it in the numerator.
Just never worry about it.
Nope.
Okay.
Nope. Because we can have 0 on the numerator. You know what I mean? Okay? Because we can divide 0 divided by any number is still 0.
Yeah.
That's real. But when I flip that around and I have some number divided by 0, then we've got dogs and cats living together. Mass hysteria. Okay?
Why is number 5 not negative 1 equals x?
Because I added x to both sides. If you would subtract 12 from both sides, you'd get negative x equals negative 12. And you still haven't solved for x yet. If it was 12 plus x, then yes, then I'd subtract 12x from both sides. Okay? Last page in your packet is this problem. Okay? Consider the graph of the value for the table of x squared and all that fun stuff. Okay? So now instead of doing, so what I want you to do is just like what we did on Friday, I want you to fill in the table, graph that function, answer those questions. Okay? You can use a shoulder partner if you need to. I'm going to give you 10 minutes to do that, and then I will go through it.
When you record,
I will not
read us.
What?
When you record it, is like.
Okay, and here's it. Okay, so q of x. You know why we went with q?
No.
What kind of a function is q of x? It's quadratic. That's why I went with Q. Okay, all right? And it's quadratic. What are we doing in a quadratic function? We are squaring it, right? Okay, so we're squaring a value. Okay? So, if I find all that, that's great. Now, let's look at R of X. You know why we went with R? Nope. What is R compared to Q? Looking at it right in this general area right here. R is a fraction, but what kind of a fraction? Remember, quadratic starts with Q. It's not quadratic though.
It's rational.
It's a rational function, yes, but that's not why we went with R. That's a good R word though.
Is there a reciprocal?
Say it louder, dear.
Is there a reciprocal?
It's the reciprocal. What does reciprocal mean? Not opposite. Flip it. Okay? Flip it. Okay? So on all of these, R is just the flip. So 1 over 1 flipped is 1. 4 over 1 flipped is 1/4. 9 flipped is 1/9. 16 flipped is 1/16. 25 flipped is 1/25. 1 flipped is 1. 4 flipped is 1/4. 9 flipped is 1/9. 16 flipped is 1/16. 25 flipped is 1/25. Why are they all positive? Because it's squared. Anytime you square a negative number, that becomes a positive number. Okay? All right? Now let's break it down a little bit farther. Okay, let's get closer and closer to 0 now. 1 flipped, still 1. 1/4 flipped
4.
is 4. 1 over 100 flipped, 100. 1 over 10,000 flipped, 0 flipped.
So divide.
Johnny? Undefined. What does that mean from Friday? Okay, it never touches, right? Or so what do we have there then? What kind of asymptote? Vertical asymptote there. Okay? 1 over 10,000 flipped then is back to 10,000. 1 over 100 flipped is 100. 1 over 4 flipped is 4. 1 flipped is 1. Fantastic. Now we can graph that function. Okay? So, if I'm graphing that function off of that chart. So, first off, because we had an undefined, that looks good there, that means we said, a vertical asymptote. So our function we cannot have a value of our function at x equals 0. Okay? Undefined there. Then, we said over at negative 10, it was at positive 1/10. At negative 5, it was positive 1/5. At negative 2, it was positive 1/2. At negative 1, it was positive 1. At 1/2, it was positive 2. At 1/10, it was positive 10, and so on and so forth. Okay? And then it mirrored on the other side. Okay? So that our function looks like that. Bless you. One more. Okay. So there's the graph. Best describe the graph of R of x and how is it similar to g of x from, well, not really yesterday, but from Friday. Just somebody watching the video.
Two separate graphs.
Two separate. So what do you mean?
It's similar because it has two separate graphs.
Okay, because it's divided up into like two parts. Okay, that's so it's similar in that regards. How does it differ?
Both graphs are white.
So in this today they're both positive. Friday they were one was positive, one was negative. Okay, all right. Any other similarities or differences? Okay. So, describe the end behavior. So our function again came through here and here. I'm just going to sketch this one. Okay. End behavior as x goes to infinity. As x goes to infinity, that's right there. As x is going to infinity. So is that left side or right side? Right side? Okay. What's our function doing?
Which is 0 from
It's going to 0 from above. As x is going to negative infinity, what's our function doing?
It goes to 0 from above.
Same thing? Okay. Okay. Describe the behavior of R of x as x approaches 0 from the left. So as x approaches 0 from the left, what happens to our function?
goes to infinity.
Goes to what, Jacob?
Goes to infinity.
Positive infinity. Okay. From the right now, as x approaches 0 from the right, what happens to our function? Goes to positive infinity. Okay. Describe the domain of our function. Domain of our function. All real numbers, right? Okay. Do we have any restrictions in the domain?
X cannot equal 0.
X cannot equal 0. Any other ones? Okay. Range. What's the range of our function? From the graph now. Because we can see something, right? We can see a graph. That means we're going to have all real numbers. But we're going to have some kind of a restriction, right? Okay. Any other ones?
Y can't go below 0.
Okay. So how could I say that in math speak? Where y can't go below 0 and y can't equal 0. How can I say that in math speak?
Y has to be greater than 0.
Y is greater than 0. Okay. We talked already about the vertical asymptote, where that's x equals 0. Remember that your vertical asymptotes come out of the restrictions in your domain. Okay? So that's anytime that if you're going to have a restriction in your domain, that's going to give you a vertical asymptote. Okay? Horizontal asymptote. What's that? How do we describe it on Friday? Here it is y equals 0, but how did we describe it on Friday? So how do I know that this is y equals 0 is my horizontal asymptote? As we go out to the extremes, right? Okay. This comes from our end behavior. Okay. Your horizontal asymptote comes from your end behavior. Okay. Vertical asymptotes, you might want to write this down. Vertical asymptotes come from restrictions in the domain. Horizontal asymptotes come from end behavior. Okay. Horizontal asymptotes have nothing to do with what's going on in the middle. It's all about what's going on at the infinities. Okay? Did you write that down?
What?
Yeah, exactly. Yeah. Okay? Alright? This blue 7.1 homework is due on Friday. Okay? Friday of this week.